Hi there, welcome to your lesson on right angle trigonometry. Now, I'm curious. Everybody has a history of trigonometry. Everybody's studied different things. I'm wondering, how much have you studied before? Have you done only the basic trig ratios, sine, cosine, tangent? Have you gone beyond that? We don't know, but this one is going to be a basic video that reintroduces you to the trig ratios and applies them a little bit. So, very big idea, kind of central to our work in geometry. Let's begin. What is trigonometry? Trigonometry is the study of how the sides and angles of a triangle are related to each other. Trigonometry comes from the Greek words that mean triangle, measurement. Okay, here is a right triangle. We talked about this when introducing the Pythagorean theorem. In a right triangle, we have two sides called the legs, and then across from the right angle in the right triangle, we have a third side called the hypotenuse. This is important for our work with trigonometry. So, to go a little further, let's say we have a right triangle. We can see the hypotenuse here, but I've marked this angle because trigonometry always begins with what we call a reference angle. In this case, we're going to begin with angle M. When we go from angle M, there's a hypotenuse, and then you can go beside angle M. This side beside it has a very special name. What is it? I hope you remembered from your work in trigonometry. It is called the adjacent side. Adjacent means beside. So when something is adjacent to something, it's beside it. So that side is beside that angle. Okay, great. Now, what about if we look across the triangle? So across from it, what is that side called? I hope you also remember that's called the opposite side. It is the side opposite or across from. Okay, so in relation to this angle, we have an adjacent side, opposite side over here. Okay, now let's say this is our reference angle, angle J. So now, there's our hypotenuse, always in the same place, but what is this side called here? That was called the opposite a moment ago. Is it still the opposite? Nope. In this case, it is the adjacent side because it is now beside angle J. So the reference angle changes what these two will be called. Look across from J, that is called the opposite side. Okay, important to know. So which leg is opposite angle B? Well, that is FH. Which leg is adjacent to angle B? Well, that is BH. Which leg is opposite angle F? That is BH. Which leg is adjacent to angle F? That is FH. And let's take some notes. So with that introduction, we're ready to take some notes and try some problems together. In your notebook, let's look at these 6 triangles, and the reference angle is given as the purplish dot, and you want to label all the other sides with H, O, and A appropriately. Try it now. And now check your work on those. I would suggest always beginning with the hypotenuse because it's always easy to recognize where the hypotenuse is. And then using the reference angle, look for the adjacent side and the opposite. Okay, hope that was no problem. Let's move on. Trigonometric ratios. There are these 3 basic ratios we always use, and they are basically equations that show a relationship between a reference angle and the sides of a right triangle. One of them is called the sine, not sin, sine. Okay, written fully, this would have an E at the end, but we abbreviated S-I-N, sine. The sine of angle A, so we always write sine of some angle, of that angle. Sine is always opposite of a hypotenuse, so the opposite side over the hypotenuse. Whatever the length is there and the length there, the sine equals that. Okay, cosine. This is cosine. Written in full, it would have I-N-E written here, so cosine. Cosine of angle A is always the adjacent side divided by the hypotenuse side. Or the hypotenuse, sorry. And tangent is always the opposite over the adjacent side. So tangent of angle A would be opposite over adjacent. Note those down. You probably know them already, but let's make sure we understand. Those are easy to remember using this kind of acronym, SOHCAHTOA. And that comes from sine is opposite over hypotenuse. That's so. Cosine is adjacent over hypotenuse. That's ka. And toa is tangent is opposite over adjacent. SOHCAHTOA. Easy to remember. Why? It sounds like you're saying soak a toa. Imagine a big foot dipping into some water, soaking those toes. SOHCAHTOA. SOHCAHTOA. All right. A lot of students begin any test that has to do with trigonometry by writing this on top of their page so they can always quickly refer to it. All right, so knowing that sine is opposite over hypotenuse, what would sine of angle B be in this triangle? Sine of angle B, opposite of hypotenuse, 6 over 10. Great. What would tangent of x be in this right triangle? Tangent is opposite over adjacent, therefore that. Check your work. And finally, what would cosine of x, angle x, be in this triangle? Cosine is adjacent over hypotenuse, therefore that. Okay, hope those went okay. Let's keep going. So now, grab your calculator, make sure you are in degree mode. Okay, the way to ensure you're in degree mode is to press the mode button right here, mode. And once you've pressed mode, you'll see this screen, and there should be an option radians or degrees. I'm going to go down to that because mine's in radians. I'm going to arrow over and press enter. Now I'm in degree mode. Now to get out of this menu, I'm going to press second and then quit here. So now I'm in degree mode. Make sure you've done that as well. Okay, now that we are in degree mode, we can do some trig problems. Here's a right triangle with one known angle, one known side, in this case the hypotenuse. Once you know two things about a triangle, about a right triangle, you can use trig ratios to solve for unknown parts. In this case, we want y, that leg. Okay, which trig ratio would you use? The way you begin is you look at your reference angle and you say, hey, this is hypotenuse, there's adjacent, there's opposite. We are not using the adjacent one at all here, so we're going to focus on just the opposite and hypotenuse when we write an equation, because we need this one and we know this one. So which trig ratio combines those two? Well, that is your sine ratio, because sine is opposite over hypotenuse. So you write sine of angle 42, or sorry, sine of 42 degrees for that angle is opposite y over 37. This can be solved now. You can punch this on your calculator, but first, if we want y, we're going to multiply by 37, and then punch down your calculator. You should get this answer here. If you did not get that answer, maybe you're still in radian mode. Make sure you're in degree mode. A little bit of history here. The word sine started out as a totally different word, and it passed through Indian, Arabic, and Latin before becoming the word we use today. So basically, it was passed culture to culture, and they kind of changed the word that it originated as. It was mispronounced, actually, over time, and then it became sine. Interesting history. Okay, let's try another one. Look at this triangle, and again, think about the reference angle, 63 degrees. Decide which two sides we're talking about here in relation to that angle, and then decide which trig ratio to use. So what will you use here? In this case, I hope you saw, okay, we have the opposite side and we need the adjacent. We don't need the hypotenuse at all. So the trig ratio that brings together opposite and adjacent is the tangent ratio. So tangent 63 equals opposite over adjacent. Now the x is in the denominator. Whenever we're solving an equation where you have something like this, you can just multiply by x on both sides, and that means that x will go here, and then you'll divide by tan 63, which means that tan 63 will go down here. So easy way to remember is you just swap these two values like this. That x goes there, that tan 63 goes there. Now punch this on your calculator, let's see what we get. Your answer is 10.19. Great. Let's try this one. Now we have another right triangle. This time the angle is the part that is unknown. So I'll show you what to do with that, but first let's begin with which trig ratio. In this case, it's a cosine, because we have this reference angle, we have the adjacent side and the hypotenuse. And adjacent and hypotenuse is cosine. So cosine of this unknown angle, this time we don't have a value put here, we just put x, that's the unknown, equals 8 over 13, adjacent over hypotenuse. Now for that, you need to do something called an inverse cosine. Whenever the angle is the unknown bit, we go to what's called an inverse cosine, also known as arc cos. Okay. So that is on your calculator. On your calculator, if I go to here, here's the calculator. Instead of pressing cosine, we're going to press second and then cosine, because above that you can see in blue cosine with the little -1. That's negative. That's arc cosine or inverse cosine. And then I'll put 8 divided by 13 here. Close that parenthesis, enter, and we have our answer there. Does that look right? Something doesn't look right. Let's see what we got here. That gives me that angle, completely different. Does that mean I'm still in radian mode for some reason, even though I changed it already? Let's check. Mode, yeah, for some reason it reset on my calculator. I don't know why. Maybe it's shut down from, I'm going to go there, enter, second, quit, go back to there, arrow up to that. I can copy it by pressing enter. Now I've copied it, and now I'm in degree mode for sure, so I'm going to enter. Oh, there we go. There's the right answer. I can see it here. Okay, so you'll know when the answers look kind of strange and the angle doesn't make sense, you know you're in radian mode, so change it to degree mode. Okay, there's our answer. Let's go punch this in your calculator. What do you get when you enter tangent of 27 degrees on your calculator? Well, you should have gotten 0.5. Let's take a look at why. Here is a small right triangle. Here's a bigger version of the same triangle. These triangles are in proportion. Notice this side 6 becomes a 12, so we doubled it. Notice this 12 becomes a 24, we doubled that. 13.4 becomes 26.8, we doubled that. So this triangle is scaled by a factor of 2, but they are the same triangle essentially, just one's bigger, one's smaller. Those kinds of triangles are called similar triangles, and we can see that they also have the same 3 angles. Similar triangles will always have the same angles. So now let's try tangent right here. Tangent of angle C in this one here is opposite over adjacent, 6 over 12. And that's 0.5. And that's what your calculator just told you for tangent of 27, isn't it? Let's try over here. Tangent of angle C here is opposite over adjacent, 12 over 24. That will also give 0.5. So notice tangent of angle C, which is 27, will always give the same answer, no matter the triangle, because even as a triangle grows in size, the sides remain in a certain proportion to each other, in this case 0.5. So that is why tan 27 is always 0.5, no matter how big the triangle gets to be. Very important to know. Will it always equal 0.5? Of course it will. All right, here's another demonstration of that. We have 2 triangles that kind of overlap, and I'm looking for sine of 23.2. So sine of this angle. Punch in your calculator. What do you get? Well, sine of 23.2 should give you this value here. Okay, let's double check on our diagram here, if that works. Okay, that's what you get on your calculator. Let's check. Sine of angle A, we can say if we're looking at the little triangle here, just a little triangle, sine is opposite over hypotenuse. So 3 over 7.62. Great. That gives us, the same value. Excellent. Now let's extend it to the bigger triangle here. So we're still going to do sine of angle A, but now we're going to look at the whole triangle. So opposite side is 4.2 right here. And the hypotenuse is now this entire length. So you have to add up 7.62 and 3.04. That gives us 10.66. Guess what? Those will also give this, because this little triangle and this big triangle are 2 similar versions. They are the same triangle, just one's bigger, one's smaller. They have the same angles. That's what's important. So the sides stay in proportion, and therefore sine of angle A, no matter whether we're using little or big triangle, is always going to be the same. Let's try that for cosine. Let's try cosine of 23.2. That should give you this value here. Double check you got that. Now let's do cosine in the small triangle. What sides are you going to divide to do cosine of this angle in the small triangle? Well, you're going to divide adjacent over hypotenuse. Great. Guess what? Same value. Now, set up a cosine equation for the big triangle. What should it be? You should have gotten 9.8 over this. Why 9.8? Because cosine means adjacent side, which is this whole length now. That's 9.8 divided by the full hypotenuse, these values. And guess what? The same thing again. It holds true. Excellent. Works the same for tan. We won't go through that, but it's the same. I have tan set up there. It works the same way. All right, now you're going to try 3 kind of problems to just double check your understanding of these 3 trig ratios. Let's go. Number 1, solve that. That's a pretty basic problem. We're looking for cosine, and if you solve it, you should get this. Let's try another one. Looking for angle A in this one. Great. You set up sine, hopefully. You notice that the angle is the unknown, therefore we went to inverse sine or arc sine, and you should get this angle here. Hope you got that to work out. And final one, we have this. And let's check our work. There's the simple trig setup for that triangle. CB, when we set that triangle up here, we find the length or the height of this part of the tree, but we don't know the height from the ground to that part. So this is not the full answer. And that's why it said, what other information do we need to know? Well, if, who is this person? Emma is standing here. This would be like Emma's height here. So we would need to know her height, or I guess the height to her eyes maybe. And then you can add that height, like where I'm moving the mouse here. Add that height to the value we got, and then you would have the full height of the tree. So just a little piece of missing information there. Great job. Great reintroduction to basic trigonometry. Of course, we will go further and do much more complex things in trigonometry soon.